let's talk about an $18,000 putter.
Sure.
Some pro comes to you and says, money's no object, I've got sponsors.
Yeah.
Like, make me the greatest putter ever.
Yeah.
What does that mean?
Yeah,
Like,
so ironically enough, that's like never the case.
okay.
Yeah, so like coming from the lens of a tour player, they're looking for a tool, right? You don't see a carpenter swinging a gold hammer.
Yeah.
Right? They're swinging a titanium hammer with a, an alloy handle grip, whatever is going to help them get the job done the best they can, offer the most consistent results, and be good quality. And so more times than not, a tour player is actually looking for like the simplest thing they can possibly get their hands on.
Hey everybody, welcome to Shop Talk, the podcast series where we talk to makers, designers, and engineers from shop to shop. Today, I'm headed to Olson Manufacturing in Humboldt County, California, home of the Redwoods and Logan's Awesome Putters. Logan's going to give me a tour of his state-of-the-art CNC shop where he manufactures his putters, finishes them, presumably does every part of the process here, way out in the middle of nowhere. So I'm excited to see how he makes it happen. All right, so for people that don't know you, can you tell us who you are and what you do?
Sure, yeah, my name's Logan. I operate a service here out of Fortuna at my shop where I make putters for the world.
I get the impression that these are some very high-end putters. Is that right?
Yeah, I like to think that a high-end is a good word that I'd mix in with there. I think that one of the things that makes my brand unique is I'm trying to tell a common story that I think a lot of brands do, but from a little bit of a different lens. I think so much of golf is caught up in like this one version of what everybody thinks like putters should look like. And I'm really trying to sort of strip back and tell it from a lot less story told way, a little bit more realer version. A shop that looks more like this versus something that may live in an art gallery, and sort of share that process from the standpoint of somebody who got started doing this with no knowledge in CNC, no knowledge in making golf putters, and just sort of having to figure it out along the way.
So no knowledge in CNC.
Yeah, zero.
And no knowledge in golf putters.
Yeah.
So let's start with why golf? Like, why did you get interested with that?
Yeah, so golf was not my initial plan when it came to this world, this field of work. It sort of ended up there, and I guess it kind of started there. But my introduction to, we'll just say like design and everything happened separate from golf. I got really interested early on. My dad built custom homes. A lot of people in my family do like a lot of hands-on type work. And so getting involved and taking like drafting classes in high school was sort of my introduction into like, we'll say a modeling world. And then from there, I was going to school with like an emphasis on engineering and engineering design, and getting more and more used to running these more complicated modeling softwares. And that was sort of my start into, we'll say like the very beginnings of the CNC land. When I was in high school, I had a teacher for woodshop that had access to like a CNC router, like a gantry router. And it was like the first time of like, oh, I can design something on a computer and then create a what to do list. And then that machine can follow that what to do list and I can get something out of that. I'm like, man, how cool is that? You get that ability to think of something, come up with something, and then have a tool that you can talk to in a certain way to make exactly what you need.
Yeah.
Well, one of the interesting things that happened was a friend of mine had introduced me to a guy that had access to like a small CNC machine in his garage. And I had sort of came across putters by accident when my brother actually was in high school, and for like a final project was modeling a golf club as like a thing to do. I was like, man, that's so cool. You can draw stuff like, stuck in the world of like drawing things for a drafting class versus like drawing like real application tools. I was like, man, how cool is that? It'd be so cool to like make one, like what would the steps look like to take something like that on a computer screen and turn it into reality? Access to like a CNC router, it's like, oh cool, make it out of wood, but like how do you make it out of metal? So that was like my first introduction to figuring out like how hard programming and the CNC world actually is. Not that conversation of, oh, you just punch it into the machine and it spits it out,
Yeah. So you start tinkering around and trying to make your own putter, and then what happens after that?
Yeah, so, barely dipping my toes in the water of like, how can I make this out of wood? And thinking that you have sort of a grasp on it, but like a material like wood is so forgiving. And so you can make a lot of mistakes and it doesn't really show. And And so then it was like, okay, how can I go from making something out of wood to making something out of metal? And zero metalworking background like whatsoever, like drilling holes in metal, nothing. And so, you know, your immediate thought is like, oh, this directly applies, just a harder material, no big deal. And so that the teacher that I actually had in high school with access to that router introduced me to this guy. His name's Bill. He had like a small Tormach PCNC in his garage. And Dave introduced me, and he's like, hey, I got this ex-student, you know, he's been taking classes at college, and one of the things that came up is like, you know, he wants to take this part that he helped model with his brother and like turn it into metal. Show him a CAD file, and he laughs, and he's like, you have no idea what you're trying to make. You have no acknowledgement to the skill set that it's going to take to execute that. And so then, you know, following that, I ended up spending about a year in his garage, like learning fundamentals on things. He had a background in manufacturing. You know, he worked on like all kinds of parts his whole life, I think, with like family members and or whatever. So he had like a Hardinge lathe, like a Bridgeport J-style milling machine. So his background was in like manual machining. My background was only in like computer drafting. So being able to take that skill set of like fundamentals, apply it to my modeling skill set, and then like be able to actually make programs that like make stuff. And so, you know, obviously hooked immediately on that. As soon as I can take something, make it out of metal, and like have a thing that you can use, I'm like, this is so cool. And then that completely killed my like interest in going to school anymore. Go to my parents, like, I want to start a job shop where I could like make stuff. Humboldt, this area is a really weird place because we're so detached from a lot of industry here. There's not a lot of industry here. So no resource for like a job shop, no ability to like take a thing that you want to make and like just pay somebody to make it for you to see if you like it. Like, how cool would it be to have like a resource like that here? To go buy a super cheap old used CNC machine, lease a building I can't afford, have no skill set whatsoever, no business knowledge. Be like, I'm gonna run a job shop. This is so cool. What did I get myself into, you know? And I ended up taking on a lot of design work, not a lot of CNC work because I was really bad at it and didn't have any experience on how to like quote a job or anything like that. So I did some design work for some local companies, and finally got into a position where I was like making enough money to like sort of run a business, but it wasn't like profitable at all. Like, this sucks. I got all this equipment, not all this equipment. I got some equipment. Like, why am I not using it? The only thing that I'd really made that I had success making before was like a putter in a garage. And like, okay, got this equipment, got this tooling. Like, let me try this again with a little bit more skill. And it turned into this thing where I was just, you know, making a putter for a friend or a friend of a friend. And then slowly it just sort of like engulfed the design side of the business that I was running, and then rapidly ramped into like a full production, like custom putter shop.
Okay. So it starts getting around word of mouth.
Yeah.
Is this part of the state known for golf? Like, do you have pros coming through here to play the courses, or?
Yeah, so absolutely not.
Okay.
Right? So we're way in this isolated area of Northern California. There is some golf here, but it's small.
Yeah.
So it became this weird thing where there's this completely worldwide group of these like putter collectors that are just out there, and you don't find them, they find you. And so it's super tough in the beginning. You fall into this realm of people like, oh, replicate this or copy this or do it exactly like that, and you know, you're just doing what you can to make money. But then I found that, you know, once you sort of build up this reputation through the execution side, right? It's through the manufacturing practice, it's through the tool paths, it's through the fixturing knowledge, it's through the meat and potatoes that are actually making the product. If you can do that well, then you can sort of build a reputation like, oh, this guy's actually making a product. And then finally you can have a voice again. And so that transition happens where, you know, I went from being a guy that people went to when they wanted something to standing in line to buy one of the things that I create. And that was the big change and the big shift. And then I had a wait list that was, you know, 18 months long to get a putter. And I was selling putters anywhere from $800 to $18,000. And so it finally became a thing where, you know, people were gracious and curious enough in my artistic ability to come to me with these limitless budgets to say, you know, make something elaborate or make something extravagant. And then I got to get the tuition of learning how to do that by somebody's request for a project. And that was when it really kicked in for me that like, oh, I'm only limited by how creative I can be to solve this problem. Because in the beginning, it's like your customization is an engraving. And then pretty soon your customization is like a new material. And then pretty soon your customization is like inlays. And then you got like all these organic forms and these organic shapes and like leaving very unique textures on surfaces and really utilizing the power of the softwares to make this picture in your mind come to life. And that was like, oh, I get this now. Like this has a lot of real estate to go a long ways.
Yeah.
And back to the question of like, is golf big here? Golf is not big here, but the community of golf stretches worldwide.
Yeah.
And in our modern society, you're one click away. And it just turned into a thing where even though I'm in, hillbilly nowhere, I can make putters for people at the elite of elite places. And I'm only separated by a click,
Yeah. We'll see examples, I hope, of some stuff you're really proud of.
Sure,
that,
yeah,
like
absolutely.
really shows off all your cool ideas and everything. But maybe we could start with just walking us through. Like you go from this piece of heavy metal carbon steel, and you have a series of steps on your machines where you go from the raw material to the finished product. Could you walk us through that?
Absolutely, yeah. So good example of some carbon steel right here. The majority of the work that I do is out of stainless steel, but I've worked with all kinds of materials from titaniums to aluminum alloys, carbon steels, all ranges of carbon steels, stainless steels, coppers, brasses, you name it. I've basically made a putter out of it essentially by now. And from the perspective of like making it, one of the reasons that I was always so like enticed by this idea of like having a shop and being able to create stuff is the conversation of the architect and the builder. So you got these architects and they design these beautiful buildings and they create all these plans and you give it to a builder and they're like, how are you gonna make this? There's this divide where somebody who's designing it is not giving consideration to the steps that it takes to make it. So oftentimes for me, more than just like getting the material and getting started, it's like, well, how do I approach this from the perspective of I have to make this at some point, so I design with the intent to make. And that's huge. And I think that so much of modern practice of having all these groups of people involved, and you've got designers, and then you've got engineers, and then you've got applications, and then you've got these programmers and machinists. So much of the product's been baked in by the time it gets to the people that have to make it. So much cost comes with the actual execution because they design features that are impossible to machine. Nothing's impossible, but very challenging, very expensive.
Sure, expensive, yeah.
And so like trying to come up with a design that's like manufacturable from the beginning, or design features that are able to be, accessed, is huge. And that's something that I really tried hard to implement from the start, is like understanding the fact of no matter how cool this is, no matter how awesome it looks, I gotta make it at the end of the day. So how can I design something that gives me the ability to make it? And I started with a 3-axis machine. So my design and my ability to make it conversation looks wildly different than it does now, right? Because now I have essentially limitless freedom with how I want to design, because I have equipment and knowledge and software that allows me to access the most impossible feature. And so from start, material shows up. Next step, okay, what will the fixturing look like? What will I have to design to hold this so that I can make the part to complete whatever design that I need to complete. And then it's like, okay, well now how to hold it in a second operation, because you have to hold on to material in the first operation.
So this is your stockpile.
Some of it, yeah.
I mean, there's I only see like, what, 4 or 5 different shapes.
Yeah, totally. Yeah, so I'll have like, this shape is, for me, like a rapid fire shape. And what it is it's a piece of rectangular billet that's been water jet into this L shape.
Yeah, I can see the curve on there.
Yeah, a lot of these putters, sort of simplified form, is this sort of L shape. So if I'm making a one-off putter and I gotta have this super fast turnaround time, this alleviates the need of extra material, and it also cuts down the cost of just having to burn a bunch of material if this was a full rectangle. Now, from the point of view of like production, you're trying to maximize the amount of pieces out of the material as possible. You're trying to, work holding density, you're trying to fit as many pieces in as one time as you can. And so a piece of material like this gives me the ability to fit 2 pieces in at once.
Oh, sure, yep.
And so these are made 2 at a time. 80% of the putter blade work that I do comes out of these 2 starting stock material sizes. And that really helps simplify from a fixturing side, because I only have to have a single fixture to start with for off one, and it makes it I don't have to have this these just millions of fixtures to make things.
Yeah.
For Op 2, because it's geometry specific, you have to have a lot of different ways to hold things. But Op 1, it simplifies it like that.
Yeah. And this looks like 5-axis to me?
Yes, correct.
So you do one 5-axis operation on these two. Then when you're at this step, you've got soft jaws for this particular model.
Yeah. So I run a global pallet system for like all of my machines. Everything that I use runs off of like a 0-point clamping system.
Okay.
The one that I use happens to be from 5th Axis. And so it uses a pull stud based system. I'm sure you're real familiar with. I'm sure a lot of people are. It's great. It's fast. It's affordable, and it gives me the ability to sort of, how am I going to put this? Create like one system for everything. And with the Op 2, I try to come up with a solution that's flexible.
Yep.
And so this pallet is responsible for 50 different shapes of work holding at once. So there's dowel pins and multiple axes. There's modular work holding solutions with like Uniforce clamps and other like bridge strap style clamps that give me the ability to hold these inorganic shapes without marring the surface, accurately locate them, and also rigidly hold them so you can cut them as fast as possible. And so all these pieces, pull out, it's like a big Lego stack.
Yeah. So this one fixture, how many different putters could you do Op 2 on? 50?
At least 50,
Wow.
rights, lefts. And so like, I'll show you. So anytime I do work for a client, well, not a client, let's say, I'll simplify. Anytime I'm doing work for like a tour player, there's a good chance that revisions need to happen. There's a good chance that we need to revisit something later or redesign from an existing model and change little things. And so I will save an exact piece of a fixture, because like, for example, this piece marries against another piece of geometry perfectly. It's a perfect mirror image. It fits exactly. And so this one piece I'll save, and it'll be like part of the fixturing setup that clamps into that pallet that I can use over and over again. And so for like a player like Scotty, I've done, so many putters for him. There's so many different fixture pieces where there's all these different components that are unique to one piece of geometry that I can, go back to and revisit. And so they're all labeled, they're all numbered, and they all are different shapes, and they give me the ability to use one palette, as you can see they're completely different, to change in and out of different styles or different head shapes, different geometries, and give the freedom to like make whatever I need to make without having to start over from scratch every time.
This is I'm really impressed with your system here.
Thank you.
And where does 3D printing come into it? So this is obviously done on a SLA machine.
Yeah, correct. Yeah, so 3D printing for me is somewhat of a new practice. For a long time, I actually didn't really see the power of printing because I have these machines at my disposal.
Yeah.
And I would make the argument that like, I can make from start to finish a product faster than you can print it. Why would I waste my time?
Yeah.
Come to the flip side of, okay, now I want to design something and I don't want to invest the time in making it, and I can let another practice happen in the background while I'm working on something else. And so I use the Formlabs printer basically as a rapid prototyping overnight.
Yeah.
And so I'll design all day long, come up with something I think is cool, set it up in the printer, walk away, come back in the morning, didn't have to do any setups, no tooling, no wear, no anything like that. And I can see a general shape. Now it's not perfect, right? It's not metal, it's not exact, but it gives you a real rough idea of what you're looking at.
Yep.
And one of the things that I found time after time is you can design something on a computer screen, and when you see it in real life, somehow it's always a little bit different.
It's always different, yeah.
And especially with something that's very visually impactful, like a lot of players are really looking for something visually super specific. And design it on a computer screen, you make it, and it always sort of looks different.
Yeah.
And so having the power to revisit and iterate and do things on the back end that doesn't really cost anything, resin's cheap.
Sure.
The cost to operate those is way cheaper than running one of these.
Yeah, absolutely. Yeah.
It's a really cool way to come up with iterative solutions without investing a ton of money and time at something.
Do you ever send these off to the golfers?
Not so much.
Yeah.
And the only reason being is when I send them something, I'm trying to intentfully interact. And I don't want to have it be a casual thing.
Sure.
Right? They have so much going on. I have so much going on.
Right.
The amount of time where we can both connect in person to do something is limited.
Yep.
And I want to make sure that that's as polished and perfect as I can.
Yeah, it makes sense.
These are more for me versus for them.
Yeah. Let's talk about your machines next. Okay. So you'd start, so that the OpZero then would be on a 3-axis machine?
Yeah, so that's like a 3-axis and a 5-axis, right? It's got a trunnion.
Oh, you got a trunnion on that one?
Yeah.
Oh, cool.
Yeah.
Let's check it out.
Sure, yeah. So this would be like, for me, for the work that I'm doing, because the demand for accuracy, speed, and flexibility is so high. When I say flexibility, I don't mean like the machine is actually flexible.
Right.
I mean the ability to be working on a lot of different things at once. This machine doesn't really solve that problem for me. It's great for stock prep, it's great for certain things, but the tool magazine size really can be impactful when you're trying to run a lot of different parts at once.
Yeah.
That's a 31 tool. This is a 120 tool.
Yeah.
And so I've got the ability to not set up and tear down a million times, where I can just sort of keep rolling. So I do a lot of stock prep on this machine.
Yep.
So dovetail cutters, face mills, profile mills, chamfer mill, stock full of that.
And you got a really big platform because you're able to do 2 different operations at once. You could run the trunnion, or you could just do
Correct.
like this plate for the 3-axis.
And when I bought this machine originally, the sole reason I actually got this machine was the fact that you have a VF2 plus a 5-axis. You stack it at the end of travel, you can measure it. It is a VF2 plus a 5-axis. And so you get the work envelope of a pretty standard 3-axis mill with the ability to also run 5-axis. And theoretically, if you needed the work envelope space, you could tear that off and run a big 3-axis platter. These machines make money when you spend the time upfront in the design work.
Yep.
The fixturing, the programming, the setup,
Yeah.
and you make one's good, and then you print money. You just run and run and run. And what's been so funny is somehow in this world of custom golf, you can still find a way to have these be profitable, but you're always sort of stuck at the mercy of being a babysitter.
Yeah.
And until I'm running production, I'm a constant babysitter because tool lengths, work coordinates, program problems, all these things sort of
Surprises.
stack up over to surprises. And I don't care how good of a machinist you are, you're gonna have a problem.
Oh yeah.
And especially if you're working long nights and doing all kinds of stuff. And so whoops, absolutely there's a whoops.
It happens. It's what the work ultimate's for.
Yep.
Okay, so you got the Haas 3-axis with a trunnion, so you can do 5-axis on it if you want.
Correct.
Usually OpZero is on here, so your first step when you're making a finished product.
Yeah.
And you got 31 tools in this one.
Correct, yeah.
This one has 120 tools, you said?
120 tool magazine.
Okay. Yeah.
It's a monster.
Wow.
Yeah, it's an absolute monster. And from a capability side, one of the things that, again, trying to transition. So I had a 3-axis machine when I first started. That machine has a 4th axis on it. You start unwinding the potential of like, where can I take this? And from a cost standpoint, as much as this is expensive, this was a much more achievable price point to get into 5-axis.
Right.
For me, the conversation around 5-axis is not so much, it's so much harder, but it makes you think in a different way, because now you're designing from the start way different, because now things that were impossible to do, you can articulate and you can hit those features.
Yeah.
And then like from a simultaneous standpoint, then the complexity really starts to add up. But in like a 3+2 land or like even like a 3+1 land for a 4th axis, you just start thinking different because more things are accessible.
Yeah. So let's stay on the operations per putter track.
Sure.
So you started, OpZero is on here.
Yeah.
Then you're moving on to Op1. Where's that happening?
Yeah, so the Op1 is going to happen in here. Meat and potatoes, right? This is where we'll say 70% of the program volume is happening. Having the most amount of material removal, the longest cycle time, the most amount of tools involved. And again, the magazine being so big, it lets me do a few things. It makes super accurate fixturing on this machine. The accuracy of this machine's over the top. It's got glass scales on every axis. You can hold tenths all day long.
Wow.
And gives me the ability to make super accurate fixturing for every machine, but also make any part that I need to make on this in this Op1 sort of world. And again, from different materials, you have different cutting flute geometries on different tooling, different lengths. And so I can just jam that thing full of everything from face mills to drills to profile mills to form tools to slotting mills to anything under the sun, and call out a tool with a big library and make any part I need.
Yeah, and no turning.
No turning.
There's no turning going on.
No turning. Yeah. I mean, For what I do, so little demand would be on turning, and with the accuracy of this interpolation, you can interpolate really round stuff.
Yeah. Round enough, right?
Round enough. Yeah, I mean, I make my own screws and my own like weights for putters too, and I'll just thread mill interpolate or interpolate round stuff, and you know, if I need to poke round holes instead of boring, you can just ream them. I mean, you do a lot of stuff with a vertical or a 5-axis machine, and you know, lathes have their place and their sweet spot. And don't get me wrong, I'm not saying there's no place for lathes, but for the work that I do, there's such a high demand on the milling side that having a lathe would almost be a waste of space.
Yeah. We need to get you in touch with Portland CNC. Actually, the last tour we did, Shop Talk, he's got a product line for tool tabs.
Nice. Very cool.
Super nice.
Yeah,
so we'll try to get you one of those.
I got onto this a little bit from like the Pearson thing, where just from like I call it a frozen tool library. So every machine in here has an existing tool library of 1 through 24, because that machine, the smallest tool library I have is 24, and there's standardized tooling for those tools.
Okay, yeah.
So every machine will have a 1/2-inch tool, 5 flutes, 1 1/4 inch length of cut, and a heat shrink, bam.
Yeah.
Every single tool machine shares that tool.
Yeah.
So anytime I pull out a frozen tool, it gets labeled.
Yeah.
And this machine has so many extra pockets, I rarely have to pull them out unless I'm doing a production run that's super specific with a lot of tools, or I'm changing tools out for certain things. But yeah, the only things that get chatted are frozen tools.
Cool. Okay. So yeah, you're doing op 1 on here. Is this the rest of the operations are going on with this machine?
Theoretically, yeah. And so again, from an accuracy standpoint, I don't have the ability to make it twice sometimes.
Sure.
Like my lead time sometimes is like 24 hours.
Yeah.
And I got to design something, test it, execute it, complete it, finish it, and ship it in a period of 24 hours. And so it has to be right the first time. And so I lean really heavy on this machine, just on the sole fact of, if I do my job, it's going to do its job, and the part comes out correct.
So there's some pretty complex physics going on here.
Yeah.
And you don't have a degree in this.
No.
Right? Can you tell us how you figure this stuff out? Should we go in your office to look at
we definitely can.
Yeah.
So a lot of it's trial by fire.
Yeah.
You know, you make a lot of mistakes, and at some point, all the mistakes you make turn into some success. But and then a lot of it is also like utilizing equipment and softwares that can help sort of lift that heavy weight of not having the ability to sort of dissect these problems from a degree standpoint, maybe. And so being able to use like a material library inside of Fusion, for example, is a great way to start when I'm trying to come across. A lot of times an athlete will make a request, and the request will be, I want a putter head weight of 343 grams and a swing weight at E5. And so being able to use like the material library to generate these sort of rough drafted versions of what a total weight will be. Like, okay, this component is made out of tungsten. This component is made out of T6 6061. This component is made out of 303 stainless. These are the mass properties of these combined. This is your total yield weight. That's a great way to sort of combat the fact of, gosh, how much is this going to weigh? And then from the standpoint of sound, using modal analysis to dissect, you know, what frequencies are these going to resonate at? And as a putter, you're hitting a putt and it sounds crazy, but they are so sensitive to sound and feel that I have to use these tools to help dissect these problems, because going to them, handing them a product and saying, I made this, and having them test it and it doesn't sound right, and then that door is closed, right? And so you have to do everything you can to utilize all these tools at your disposal to come to a place where you're confident with the thing that you've made, and you have to just hand it off, and it's like, okay, it's yours now, you know?
Yeah. Give us an example of a putter that took like way too many iterations to get it right.
I know we talked about Scotty a few times, but he's definitely a player that I spent the most amount of time with. I was making a putter for him every week for almost a year. 62 putter. And so back to sound, back to feel, back to testing, there was an incredible amount of time spent changing neck geometry of the putter. So like on a putter, there's a lot of different features, one of which that's commonly referred to as the neck area. So this is a transition out of the putter head that goes into the shaft, into the grip that you hang on to. And all of these dimensions in this width, this thickness, how tall this is, changes a lot of the sound and feel properties of the putter. It also changes a few other things, but it can really impact sound and feel. And using analysis to dissect modal frequency zones in different hertz ranges to try to combat what they feed back to you as like, oh, this feels or sounds plasticky. Oh, this feels or sounds too soft. Oh, this feels or sounds too hard. And so I'm using word comments to try to recreate solid models to solve that thing that they're thinking. And sometimes it's as simple and it's crazy, but it's like, I've gone and machined a thousandth off of a face texture and oh, it feels completely different now. And so they're incredibly sensitive, and whether it's real or not real, once they've decided that it's real, it might as well be real because now I got to combat that. And so that's an example. 62 times is a lot of times.
Wow.
But on the flip side, using the feedback from the best players in the world, by the time, we worked through all those iterations of this project, there was something that was really kind of special that was left behind. It's like, we got somewhere. Like, it may have taken a long time. We may have beat it up from way too many angles, but something came out of that that's pretty cool.
Yeah.
Yeah.
So let's go check out your what you're doing in software.
Yeah, absolutely. So here's a project that I've been working on. It's like a mid mallet shape. This will be made out of 303 stainless steel. And it also has a multi-material construction. There's an aluminum sole plate here that is there for mass distribution, mass removal, and also to sort of close the structure. And so, yeah, this is a pretty decent example of a very simplified model from the sense of, hey, this is the only thing on the screen. And then
is there any simulation in this one?
Oh yeah, absolutely.
It'd be interesting to see what you're doing there.
Yeah, so back to the conversation of 3-axis versus 5-axis. One of the powers that I've recently been using a lot is like full machine kinematic simulation. And in 5-axis land, this is so critical because it's hard to watch everything that's going on sometimes. And especially with full 5-axis cuts, what ends up happening is you have this point control in a motion, and then you have these reposition moves that can be very erratic. And the reposition moves are something that I really try to watch a lot with. And one of the cool things that I could do here in the manufacturing menu, which I'm sure you're aware of, is you can build out your entire tool stack. You can build out your entire machine, which a lot of times is provided either through Fusion or through the manufacturer. And you can do a full machine simulation to simulate the entire cutting process. Now, it's not going to tell you things like, hey, your step over is too big, or hey, this cut's going to leave poor surface finish, but it gives you a real good understanding of sort of a physical thing that's going to be happening before you have to walk out there. Because what's really great is to watch a simulation spindle crash into a table versus a real spindle crash into a table. So we can simulate with the machine here.
How many operations is this?
That's over 100.
Lord.
Yeah, so the toolpath tree is pretty long.
Wow. And that's just for that one piece, and this is a multi-part.
This is just for one piece of that. Yeah. That's correct. So again, because we're in 5-axis land, this simulation is going to pin the part in space, and then the machine is going to articulate around the part. Now, in reality, it's almost the opposite, but this will give a general idea visually of sort of the process that I end up looking through to sort of verify my tool paths in order to make sure that everything's happening in real space correctly and things aren't crashing into each other. The majority of the work that I do, even with the ability to run, full simultaneous 5-axis, ends up being 3+2. It's hard to beat the efficiency of rotating a part and hitting a feature. Now, anytime where I'm having to attack, very complicated things and create really consistent, we'll say like tooling lines.
Is that a probe operation?
No, this is actually like an engraving trace operation. I'll use a lot of simultaneous 5-axis motion for that. And it's more a function of like, I'm trying to leave a very consistent tooling pattern on the part visually.
Right.
But yeah, it's hard.
Interesting. So you use the continuous 5-axis to get to basically that's like a surface finish. Interesting.
Yeah, and you know, as much as I keep talking about the accuracy of these parts, you know, the first thing that the customer sees is not that I'm within, you know, 5/10 tolerance.
Right.
It's how good does this thing look?
Yeah.
And it's not even how good is the surface finish, but how good does this thing look?
Right.
And me being able to control the surface finish, I can control how good that thing looks.
Yeah.
Yeah, so here's just like a little library, and we can just scrub through these really fast. But again, in the interesting materials conversation, you know, you got access to every material under the sun. Why not make a putter out of like forged Damascus, you know? So I have one here, I'll show you. They're just outrageous to look at.
Yeah, it's so, like, Damascus steel is just such a eye-popping material.
Yeah, and so like this one, you know, that combination of like cutting edge technology, interesting materials, and then also like this is a piece of hex bar that I welded on here, and I blended the weld out completely with stainless filler rod.
Whoa.
And so it leaves this transition where the filler rod blends perfectly into the head, but when you acid etch it, you can see where the filler rod is. Then I heated the hex bar up with a torch and I twisted it and then polished it out to like a mirror finish.
Wow.
Yeah, so like that one, you know, it's like, again, a piece of hex bar that I've twisted, TIG welded on, and then machined mother of pearl and inlaid that into the cavity.
So those tiny inlays are also mother of pearl?
No, these are stamped in. This
Okay.
is my logo hammer stamped in.
Got it. And then like enamel in there or something? Or
Yeah, exactly.
Yeah, okay.
Like a cured enamel. And then again, this is a it's a radial tool path.
Yeah, so I love that. The tool path becomes like the aesthetic. It's so
And I've
cool.
used that exact practice my entire time, where people have always been, I think that's one of the things that people have gravitated towards my brand for, is the unique finishes and textures. And I'm like, guys, they're tool paths.
Yeah.
Like I'm tweaking the tool path, and I'm using a very cold thing to make a very warm finish.
Yeah, yeah. Love it. Whoa.
Oh yeah, so this is a putter made out of copper, and I machined a 16th ball punch out of tool steel, and I hardened it, and then I hammered the whole thing.
Yeah, I was about to say, that's like a really complex thing to do with it. Yeah, that was punch too, wasn't it? The little squares.
Yeah, so here's some copper inlays.
Man, that's pretty. Can we go look at some putters now?
Sure, absolutely. It's real
So you
close.
got your own putting green here.
Yes.
I love it. So this is where you test stuff out? Do you have
Mostly for
customers
me.
come too?
Yeah, it's mostly for me. And what's really interesting is like trying to put myself in their shoes to dissect things that they say as like word comments. So this is pretty integral in the process. Obviously, everything I make has to be tested.
Yeah.
You're giving it to the best players in the world. You're giving it to whoever. It needs to be right. So doing what I can to use my feel and my ear to dissect as much as I can. I use this space a lot.
Yeah.
Okay.
My brother's gonna make fun of me if I don't get this, so.
You had plenty on it, that's for sure.
I could sink this one. Nope. I guess I need to get to the golf course. Most people looking at that would think, you know, how is this really any different from that as far as the way it's going to behave, but it's completely different.
Yeah.
Yeah.
So again, same material, same weight, same swing weight, slightly different, you know, design.
Yeah.
But you just adjust that one variable of like how it's interacting with the cover of the ball, and you can completely change the dynamic feel.
Yeah.
Yeah.
I can see why they come to you, man. Thanks so much for the tour. This is
absolutely.
super interesting.
Yeah, thank you.
Yeah. Hey everyone, don't forget to like, comment, and subscribe to our YouTube channel to stay up to date with all things Shop Talk. If you're ready to try Fusion for yourself, find the link in our description.